All right, so we're going to take a look at 9.2, area of regular polygons and circles. In the math humor for today, what happened to the plant in the math classroom?
It grew square roots.
Not just roots, but square roots. Nice.
Get it, get it, get it?
So we're going to start the lesson by talking about the different parts of a circle. And before we do that, we're going to talk about how you can actually name circles. When you're naming circles, just like with triangles, you use a little triangle symbol. When you're naming circles, you're going to use a little circle symbol. And that circle symbol is a circle with a dot in the middle. If you ever name a circle, you're going to name it using its center. Like in this case, our center is the point A. So we say circle A. And the radius, a radius of the circle is the segment that connects the center of the circle to a point sitting on the circle itself. So our radius here is AB, or we can even talk about the diameter, which is the diameter in this instance is segment CD, and both of the endpoints of the diameter sit on the circle, whereas it has to go through the center of the circle. So one important number that comes out when we talk about circles is the number of pi, and it's an irrational number, and we get it by talking about the ratio of the circumference of the circle to the diameter itself. And the circumference, remember, is like the perimeter of your circle. And when you talk about circumference, you can always find the circumference of a circle by taking the pi times the diameter of the circle, or since you know the diameter is twice the radius of the circle, circumference can also be written as 2 pi r. So it's a really, really good formula for you to know. Circumference is 2 pi r. The other one you need to know is the area, or all of the shaded region on the inside of a circle would be pi r squared. So if I asked you to find out what the area of this given circle is here in terms of pi, so meaning leave it in terms of pi, you would take a look and see. Well, they're giving me the whole entire diameter 6, but I don't need the diameter, I need the radius. So my radius is going to be half of my diameter, which is going to be 3. So the area that I'm working with here would be pi times 3 squared. So 3 squared gives me 9, so I get 9 pi. Now, it said leave in terms of pi, so I will do so. But the other thing you have to watch out for is it did give me units, and so we're talking about area, it's going to be units squared. So we would say inches squared. Now in this example, they're asking us to find the radius of my circle J, given the circumference is 65x plus 14 times pi meters. And they also give me what the circumference formula is. So what we're going to do to figure out what our radius is we're going to write down my circumference formula first, so 2 pi r, and I'm going to fill in what they gave me. They told me that my circumference was 65x plus 14 pi. That is equal to 2 pi r. Now, in order for us to solve here, what we're going to do is we're going to go ahead and we're going to take and divide, because we have to get the r by itself, divide both sides by 2 pi. When I divide both sides by my 2 pi, I notice that the pi's will cancel, the 2's will cancel here, and what I'm going to do is I'm going to actually take the 2 from both of these quantities here. So when I take the 2 from both of these quantities, I'll get my radius is equal to, well, 65 divided by 2 gives me 32.5x, and then 14 divided by 2 gives me 7. So I have 32.5x plus 7, and that would be meters. Now continuing on with the same concept, what we want to do in this case is we want to find what the circumference of a circle is, given our area is 25x squared pi feet squared. So the first thing you have to do when you're looking at this is they're giving you the area. So if they're giving me the area, I have to start off with my area formula. So my area formula was pi r squared. Now, they gave me the area, so I'm going to plug that in for my a. So 25x squared pi is equal to my pi r squared. Got to get the r by itself. So the first thing you're going to do, divide both sides by pi. If I divide by pi, those are gone. I'm left with 25x squared equals r squared. To get the r by itself, you then have to square root both sides. So when you square root, you're going to notice that the square root of 25 is going to be 5, and the square root of x squared is x. So my answer is 5x for my radius. Now that's going to be in feet because my area was in feet squared. Now that you have the radius, now that allows you to solve for the circumference. So it was really a two-part question because you can't just jump from area to circumference. You had to solve for your radius first because I need my radius to help me out with my circumference. Now my circumference is 2 pi r. Therefore, my circumference would be 2 times pi times my radius of 5x. And we know that if I take and I multiply, I'm going to multiply my whole numbers together, 2 and 5, which give me 10. 10 pi x would be my circumference, and if we use units, it would be in terms of feet. So let's take a look at a real-world application for this. If I have a pizza making kit and it contains 3 circular baking stones and they have diameters of 24 centimeters, 36 centimeters, and 48 centimeters, I want to go ahead and find the area of each of those stones. And what we'll do is we'll round to the nearest tenth. So you're going to take and you're going to multiply it all in your calculator and use the pi key in your calculator. Why don't you go ahead and do that for me, and then when you come back after pausing the video, I'll have all the answers written down and we can check them together. Alright, so if we take a look, here's what I ended up getting. A 24 centimeter diameter ended up meaning my radius was 12. Plugging in my formula, I ended up getting 452.4 centimeters squared. 36 centimeter diameter was a radius of 18, so I ended up getting 1017.9 centimeters squared, and a diameter of 48 meant a radius of 24 centimeters. So plugging that in, I get 1809.6 centimeters squared. So we've been talking about centers of circles. We're going to take that concept and we're going to apply it to regular polygons. So the center of a regular polygon is actually equidistant from each of the vertices. It's smack dab in the middle of your polygon, just like the center is smack dab in the middle of your circle. Now when you put 2 of these equidistant length segments from the vertices connecting the center of the polygon together, we get something called a central angle. So the technical definition for a central angle is where it has a vertex that sits on the center of the polygon and its sides pass through the consecutive vertices. And I'll show that in a diagram in a minute. Now each central angle that you're working with within your polygon that has n sides, so it has n sides, makes it more general for us to utilize. Each central angle, you find it by taking 360 degrees and divide it by the number of sides. That's how you find the central angle. So I'm going to give you this diagram here, and we're going to give you that you are working with a regular pentagon. Regular meaning all the angles are same, all of the sides are congruent. So the pentagon is DEFGH, and we know that it has a center of C, so it's right in the middle, and it has a central angle that we're going to talk about, central angle DCE, even angle HCD or GCH or GF or GCF, FCE. All of those are central angles, and you notice we've got 5 of those central angles. Now we find the central angles by taking 360 degrees and divided by the number of sides. So if I took 360 degrees and divided by the number of sides, in this case, I would know that each angle I would be working with would be 72 degrees. Now, all of a sudden, we're going to talk about this thing called an apothem. Well, apothem is the distance from the center to the side of a polygon. And when I say distance, we're talking about that shortest line segment, so it's going to be the one that's perpendicular to my side. That is my apothem. Now, if I draw an apothem in, you're going to notice the apothem will actually bisect the central angle. So what it's going to do is it's going to make 2 congruent angles by my central angle. That's very, very important. And also, if you think about it this way, if you were to take and actually draw a circle in the inside of this polygon, which I'm going to try to do, and that's not half bad, the apothem would actually be the radius of the inscribed circle. Now this chart, all it's doing is kind of showing you how we ended up coming up with the area for a regular polygon, because you know the area formulas for triangles and rectangles and circles, but we want to be able to work with any regular polygon whatsoever. So if you're interested in actually developing the formula, you can talk to your teacher, and she or he would be more than willing to describe how we find the area of a regular polygon. All I really need you to know is how do you actually just find it using the formula? So the formula for the area of any regular polygon, regular, it's got to be regular, is all you have to do is take 1/2 of the apothem times the perimeter of your polygon, otherwise known as AP divided by 2. I'll usually use AP divided by 2. Now these steps are really, really important because it kind of guides you through the process of finding the area of any regular polygon. So the first thing you're going to want to do with your regular polygon is you want to find out what the central angle is. And we did that by finding the number of sides and taking 360 divided by the number of sides. After you find out what the angle degree measurement is for each central angle, you're going to take that central angle and you're going to divide it in half. And that's what happened with the apothem. Remember, we said the apothem split the central angle into 2 congruent angles. After you do that, what you're going to do is you're going to work with half of the triangle to find out what the length of the apothem is, or to help you find a side of the polygon. Once you do that, all you have to do is fill in the missing information, figure out what your apothem is, figure out what the perimeter of the polygon is, and multiply, and then divide by 2. That'll give you the area of any regular polygon. But you should always start off, find the central angle, divide it in half, use the triangle to find the missing apothem or side, and then plug it in your formula. So let's go ahead and take a look at an example here. In this example, they want us to find the apothem and the radius of a regular pentagon whose perimeter is 60 centimeters. So what we're going to do is let's go ahead and take a look at the apothem first. The apothem, that's going to be the segment that goes from the center of my circle straight down. It's that shortest distance. So that's going to be my apothem. And the radius is going to be the distance from the center to the vertex of my pentagon. Now I want to find out what my apothem is, and I want to find out what my radius is. Before I do that, I'm going to go through the steps. Even though I know it doesn't necessarily ask for the area of this polygon, I am still going to use some of those steps to help us figure out what the apothem is. So the first thing you're going to do is you're going to figure out what is the central angle. So the central angle, horrible writing there, sorry. Central angle. It's 360 degrees divided by the number of sides. And we're working with 5 sides here. So 360 divided by 5 gives me a 72-degree angle. That's what the whole entire central angle would be. So if I had the whole entire central angle, that whole angle here, that would be 70 degrees, okay? Or 72 degrees, sorry. So if that's 72 degrees, let me quickly get rid of all of that just for a second so I know I'm only working with half the triangle then. If that was 72 degrees, I then want to find out what half of that whole central angle is. So if I take 72 degrees and I divide it in half, I'm going to get 36 degrees. 36 degrees, that's what this angle is right here. Now that I have that angle, do you realize you're working with a right triangle? And in a right triangle, if you have an angle and one of the sides of the triangle, you can use SOHCAHTOA to help you figure out the other missing sides. Now, I don't have anything labeled right now, but they did give me a piece of information that's really, really important. They did tell me that my perimeter was 60. And since my perimeter of this pentagon is made up of 5 sides, I know that each side is going to be 12 units long. So if each side is 12 units long, just letting you know, the apothem actually does split the side into 2 congruent parts, so this is going to be 6. Now that I've got this triangle, the half of the triangle that I'm looking at right here, we're going to use SOHCAHTOA to help us figure out the apothem and my radius. So my apothem, my A that I'm looking for. Notice, I know the angle here. I've got the side opposite and the side adjacent. So opposite and adjacent, we're using tan. So tan of the angle, 36 degrees, is equal to my opposite 6 over my adjacent, which I'm going to say is A. If I solve this in my calculator, you are going to end up getting an 8.26 centimeters. Next, the radius. So if I'm looking at finding the radius, I know the side opposite of my angle, and the radius is the hypotenuse. So the opposite hypotenuse is using sine. Sine of the angle, 36 degrees, equals the opposite 6 over the hypotenuse, which is r. If I plug that into my calculator, my radius ends up being 10.21 centimeters. So I solve for my apothem and my radius. Anytime you have to do that, you should always start off by finding out what the central angle is, taking half of that, and drawing in that triangle. So we're finally getting to finding the area of a regular polygon. In this case, our area for a regular polygon is going to be the formula A equals AP divided by 2, like we said before, or we stated that you can use 1/2 the apothem times perimeter. They both mean the same. So in this case, we're going to find the area of our dodecagon. And the dodecagon has side lengths of 5 centimeters. We got to find the area to the nearest tenth. So what I would like for you to do is, using the steps before that we had, I want you to find your central angle. After you find your central angle, I want you to find the half of that and use it to see if you can find out what the apothem is. Once you find your apothem, go ahead and start the video back up again and I'll lead you through the rest of the process. But I want you to find your apothem first. All right, so taking a look, I found that when we're working with my central angle, since it was 360 degrees divided by dodecagon's 12 sides, I ended up getting every central angle was 30. But I don't want the central angle necessarily, I want half of it. So I take half of 30 and I get 15 for my angle. So that's the angle up in here. I just redrew the triangle so it was easier for you to see. That's my 15-degree angle. You knew each side was 5, so that meant this was going to be 2.5 in my small triangle. If I'm looking for my apothem, I know my angle here is 15. I know the side opposite. I want to find the side adjacent. So that's tan. Tan of the angle is the opposite, 2.5, divided by my adjacent A. If I solve this, I get my apothem is 9.33. Now using that, we're going to find out what the area is. So the area is 1/2 my apothem. Now here's the thing. It would be easier if I could just use, instead of using a rounded answer, I could use the setup I would have from finding the apothem in here. So if you actually have this stored in your calculator, use it as an answer then when you're typing this part into your calculator rather than the rounded answer. Or if you notice that this is the same thing as when you solve for your apothem, all you do is take that 2.5 divided by your tan of 15. It would be easier if you just took this and threw this in your calculator instead of the rounded one. So that's why I'm going to write then 2.5 divided by the tan of 15. Oof, the writing, it's getting horrible. And then multiply that by my perimeter. Now let's talk for a second. The perimeter, if each side is 5 off to the side, perimeter, each side is 5, and I've got 12 sides, that means my perimeter is going to be 60 units. So that's what I'm going to put in for my perimeter in my area formula. So in my calculator, I type all of that in, and we're going to end up getting an area of 279.9, and that'll be centimeters squared. Oh, my pen is just dying on me. Let's try this. And it's getting horrible. I'm thinking it's telling me I should stop. So do me a favor, go through these notes again. Make sure that if you have any questions whatsoever that you let us know, because this is kind of the trickiest stuff that we've got going on in this chapter, I believe. So follow the process. Find the central angle, take half of it, use that with your trig functions to help you solve for your apothem or the missing perimeter, and then all you have to do is just plug it in your area formula. Again, if you have questions, please let us know. Until then, have a great night.